All right, so we got a company that produces lag bolts, and they have this 10-inch lag bolt, and the machine was redesigned, and they're wondering basically, are the lag bolts still about 10 inches on average? There's always going to be a little bit of deviation when we make something here. Now this one, I gave you a whole bunch of information, so I could copy all of this data into a spreadsheet and then use the spreadsheet to calculate the sample size and the sample mean and the sample standard deviation. I also gave a special t-score related to the significance level, which I haven't talked about much before. I think I did it way back weeks ago when we first started doing this stuff. So I'll also explain what that means in just a minute. And then we have some hypotheses here to look at. So let's see, let's double check. You've gathered a random sample of bolts that have been produced by this new process. Conduct an appropriate test at the 5% significant level to determine if the overall mean for this process is 10 inches. Determine if the overall mean for this process is 10 inches. So they're giving us the null hypothesis. They're saying the mean is 10 inches. And actually, it's a question. Is the mean 10 inches? Which means it might not be 10 inches. So that would be a two-tail test. So for the alternative, I would go for this one right here. Mu is not 10. Right, alternative. Then the other one would be 10. So I'm going to copy some of this information into my sheet to scribble on. And then we'll try a spreadsheet 2. New page, please. All right, so let's see. We are doing a hypothesis test. For the
alpha number as well.
Yes, I'll come back and get the alpha in just a minute. Thanks. So let's see. Hypothesis test for a mean. So big thing we want there is the standardized test statistic. And for a mean, that is we call that a t-score, and it would be the sample mean minus the null hypothesis value divided by the standard error, which is S over the square root of n. And so I have some of that information here. Let's write down the null hypothesis. Semicolon, mu is 10. Right, that's what it used to be. We got a redesign, and now we're wondering, is mu really still 10? Not sure. So there's my alternative hypothesis. Little note, two-tail. And then what is alpha? And I think it was 5%, but I don't remember. 5% significance level. So this one said use the standard. So a quick sketch of what I got so far. I think the mean ought to be 10. My data came out to be a little less than 10, so somewhere out here. And the question is, how far out is it? And the answer is that depends on what the standard error is. So I don't have enough information to draw that yet. What I have been told is that that 5% is my significance level. Since this is a two-tail test, I have to split that in half. So each tail gets 2.5%. So I'm gonna have to draw a line out here that puts 2.5% of stuff in that tail. And I gotta draw a line out here and put 2.5% in that tail. And the question, does my data end up in this green region here, or does it end up in the red region over here? How far, based on the standard error, is 9.971 from 10? So we have to calculate the standard error here to figure that out. And a spreadsheet would be a good way to go from here. So I'm going to go bring that back. All right, so let's see. This is a hypothesis test for a mean. And so I'm going to choose that tab from the spreadsheet. And if anyone needs another copy of this, let me know. And this should be fine. Okay. So since I provided the summary statistics, I don't need the original data. So I can just grab those numbers. So let me pull this there for a second. So this is the, oh, I should make a copy of this so I don't mess up the spreadsheet I'm sharing with people. Duplicate. lag bolts. And then mu is either equal to 10 or mu is, I'm going to steal the not equal to symbol. Not equal to 10. And then n in this case is 20. I don't need to recalculate the sample mean because it was given. Otherwise, we would have to use the average formula to find it. And I'm given the sample standard deviation, 0.04973. My alpha is correct there, so I usually highlight the given information and then I have to calculate all this other stuff. So according to the spreadsheet, the standard error, which is the sample standard deviation divided by the square root of the sample size, is about 0.01-ish. So if I come over to my picture, so that 2.5%, that's going to be around 3 standard deviations to the left. According to that problem, I claim, where did I put that? Back here. I claim, sorry, 2 standard deviations. I claim the t-score is not 2, but 2.093. That's the t-score for the 5% significance level, not the t-score for my data. Different t-score. So that's about 2 standard deviations. 1 standard deviation would be about here then. And 1 standard deviation, that standard error right there, according to the spreadsheet, is about 0.011-ish. So this right here, 1 standard deviation to the right would be about 10.011. And 1 standard deviation to the left would be 9.989. This is 9.971, so that's over here somewhere. We got to calculate the t-score to figure out where it is. So in the middle, this would be t equals 0. In the top paragraph of the spreadsheet, I claim that mark for 2.5% is 2.093, is what it said. Yeah. Negative 2.093. This one right here is what's called the critical t-score. And that always comes from alpha. I need to find the t-score from my data up here. So that would be my 9 points, let's switch colors. 9.971 minus 10 over 0.04973 over the square root of 20. And the spreadsheet says that is about, where did I put that spreadsheet? There you go. Oops. Negative 2.6079. 2.6079. So that would be way out here-ish. So somewhere out here is my t-score from the data. That is way outside of that, what is this, 95% area in the middle. So this looks like a reject of the null. So I'm thinking reject null. To be sure, we're going to find the p-value, which the spreadsheet already did because it was set to do so. We'll check with stat key 2 to make sure. Let's see, this is a two-tail test. And so the p-value is we have to double the tail,
right? Here's the left tail, 0.008645. Doubling that, I get 0.0173 to 4 decimal places. 0.173. That is definitely less than 5%. So my suspicion about this t-value being pretty far from the center is true. We're definitely going to reject the null. That's the decision. Conclusion would mean, like, explain this to the boss who doesn't know as much statistics. So how do I explain this to him? So, okay, I'm rejecting the null hypothesis, which means this bolt length is a bit small when we were hoping for 10 based on a sample size of 20. So the data suggests the alternative is true, that it's not 10. So that would be a conclusion. We write kind of in plain English. We don't use the word null in there at all, or alternative. We just try to state it as professionally as possible without too much statistical jargon. So conclusion. Sample data shows that the average bolt length is not 10 inches, right? The alternative says it ain't 10 inches. That's what we found. It's not 10 inches. So I just kind of try to simply state that we have evidence supporting that. So sometimes I might write, there is strong evidence that the average bolt length is not 10 inches. That'd be another way to write it, right? There's lots of different ways we can use English to state this. There is sufficient evidence, strong evidence, lots of options. Could I have made a mistake here? Yeah, it could be. I just have a weird set of bolts that I grabbed, and that the mean is actually 10. So that would be a type error. I rejected the null when the null, type 1 error. I rejected the null when the null is true. So then we have to go retool the machine and try and fix it, make better bolts, and then test it again. Do the bolts the right length? Is that a huge deal? Might be good to go over it again and make sure it's working right, because it doesn't seem to be according to this sample. All right, that was fun.